Good evening friends, this is Pradeep Kumar again. Welcome to Engineering Clinic. Hope you had a VANETs routing in part number 1 we have already seen, and this is the continuation of this. This video contains part number 2, the analysis of the results. Okay, so in this what we are going to do is, so this is a very long video again, so please go through the first video and then come back to this. Please go through the first video, or we can say part 1, and then watch this video. This is part 2. Okay, in this what we are going to use, first we are going to use SUMO for web traffic. So we will be using osmWebWizard.py type file. So this file we are going to use. So number 2, convert this into mobility.tcl file, and that can be loaded to vanet-routing-compare.cc file as discussed in part 1. Third point is, we will be analyzing various metrics like receive rate, packets received, MAC, PHY, workload or overhead, we call overhead. Then we will be dealing with packet loss. Then we will be dealing with packet loss. So packet loss, throughput and other metrics. So these are the metrics we will be discussing. So there are so many files that we can generate, files that are generated. So one thing is mobility.tcl file, second thing is trace file, next thing is .flowmon, it's a FlowMonitor file, then .xml for net animation, for NetAnim, flowmon for FlowMonitor, then trace file for Ascii Trace. So this is for throughput and goodput. Apart from that, we can generate .pcap files also, so they are all for Wireshark. So mobility.tcl for generating traffic in the network. So these are the things we are going to see in this session. So I will be uploading these things into the YouTube comments also. So first what you can do is, you can refer to the part 1 video and then you come back here, else you will not understand what's happening here. So first step 1 is SUMO. So we'll come back to SUMO here. So SUMO here, so what we do is, I have already installed SUMO in the folder called as SUMO here, SUMO. So cd SUMO, then cd tools. So we have a folder cd SUMO, cd tools. You can see there are the files available here. So you can see which directory I am in. I am in /home/pradeepkumar/sumo/tools. I am currently in this directory. So now what I do is, I just check. There is a file called as osmWebWizard. So this is a file we will be having. So for running this file, you should have internet. I'll just tell you why you need internet. So osmWebWizard.py. So once you type this command, python osmWebWizard.py, so please declare environmental variable. So you can use export sumo_home equals home Pradeep Kumar SUMO. So this is the path for sumo_home. So maybe I'll just include both the lines. So first command will be include this thing. Next thing is cd SUMO tools. Then next thing is python osmWebWizard.py. So once you have done this, it will open a new browser window. So you can see that by default it will show the position of Berlin, the place in Germany. So we are going to have current location, use current location. I am just creating it. this will ask for allow or block. So allow this. Once you allow this, you will get the map of your current location. So where I stay, so I'll be getting this location here. So what I do is I'll just drag it down, and you can see select area here. So I can select the area. So once I select the area is big enough, but for smaller simulations have smaller area, so else you will be in trouble, because you need more clock speed or more powerful machine to handle the huge data, because it is involving real maps. So what you can do is you can able to take a small area here. So now we have taken the location. Now next thing is you go to the vehicles. So what kind of vehicle it has to play around. So here we have, say, by default cars are selected. So we have trucks, bus, motorcycles, bicycles, pedestrian, trams, urban trains, like this. So let me go with the trucks and let me go with the bus. So you can see as per traffic factor, the toll is nothing but count per hour per kilometer. So 12 cars per hour per kilometer. So that means that is the amount of traffic that got generated. So other things I am not touching now. So in case if you want to have multiple vehicles or multiple pedestrians, bicycles, you can include that according to the complexity. So my machine is with a 256 GB SSD and 4 GB RAM. It's just 5-year-old machine. I am just running in a MacBook Air. So I can able to process only this much. So now we have the duration is 3600 seconds. So it's such a very long duration here. So what I do, I'll just make it to 100 seconds. So for time being 100 seconds. And in case if we have left hand traffic, so that means left hand side means Indian UK conditions, they are using left hand traffic. In the Americans, they use the right hand traffic. So accordingly you select, if you untick this, it will be right hand traffic. Then the other information. So finally there's an option called as generate scenario. So once you generate scenario, downloading map data, I'll just come to the terminal, it will show you the data. So if in case we got any error over here, so that indicates that something is not happening. Okay, now you can see this map just directly the SUMO GUI have been popped out, and you can see the entire map. I got it. So just I am not doing anything, just you run the simulation. You can see the vehicles, how the vehicles are moving here. So I given that delay of 20 milliseconds, that's why it is moving at a faster rate. So simulation ended at 250. So all views are closed. So again we open it. So I got it again. So now I decrease the timing. So let's say I increase the timing, that means I make the delay to be more. Now it will be slow, the traffic will be slowly moving, you can see here. So these are the cars, and then we'll see any truck. Yeah, you can see truck, buses are moving here, and you can see trucks are moving here. So bus, trucks, so according to the size you can able to see that what's happening. So this is not much for if you are undergraduate student, showing this will be a very good work, but for a postgraduate scholars, research scholars, this could not be a thing. But how we can able to process this information into the further processing, so that we'll be seeing. I'll close this window for now, and I just close it here. So this window also I'll just close it because I don't need now. So inside this tools folder, I have folders created in like this, the time and the date. So today date is 18/8/2018, the time is 8:47 at 8. So this I tried around 7 o'clock. So this I tried around 8:47. So I'll just go to this folder 2019 and 20. Now inside this you got all the files. So this is where all the XML file that we generated using this osmWebWizard. Okay, so the main file is SUMO config. So this is the main file. So if you want to run this file, sumo-gui osm .sumocfg. Once you run this, you will get the same window. Sorry, the path is not there. So in case if you want to use the path every time, so what you can do is go to the home folder. There you can use gedit .bashrc. The .bashrc, what you can do is, I already set some path for ns2. So I just /home/pradeepkumar. Ensure that don't make any mistake over here, and SUMO. So this is a SUMO home path. Oh sorry, it is a path variable. So /bin. So export SUMO _home equals /home/pradeepkumar/sumo. So this is a sumo home, but this bin is the sumo file, the sumo GUI file, all these things will work. That's why I have the bin file in the path. So once it is done, so we can come back here, source.bash or c. Can try this. Now we can try sumo here, it will open. Sumo GUI, it will open. Yes. So now I'll just go to the sumo folder, then cd tools, then cd 2019, then 20. Yes, now sumo -GUI osm.sumocfg. You type it, you will get this. So this is what we were seeing. So in case if you want to reopen it again using the sumo GUI command, you can try out this. So I just run it again. Yes, you can see that. So this is how. So this is not our purpose. So let's see how we make things happen. Okay. Okay, now we have to generate a mobility.tcl file. So first thing is we have to convert the entire movement into XML file. So sumo handles that in a different way. We'll see the command. Okay. So the command is sumo. So we have two commands, sumo and sumo GUI. I will use sumo -c. The name of the output is osm.sumocfg. So this file we are converting into floating car data. FCD means floating car data. So output sumo fcd output space trace.xml. So we are converting everything into the trace.xml file. So once you have done, so it was telling that duration is 294 milliseconds and real time factor is this, UPS is this, inserted 333, routing length is the duration like this, and it is a register router, answer 33 queries, and you can check it here. You got a trace.xml file. So if you open trace.xml file, this is how it looks like. So every vehicle movement is recorded here. So the total number of lines will be around, it's unpredictable, so around 4600 lines. Anyway, we are not going to process this, and sumo will be processing this file. So we have this command. So anyway, just open, copy this command. So this command you will be doing. So after it is done, once the data generated, so this thing will be doing. Okay. So this is OSM sumo config and fcd output trace.xml file. So then what we do is, now next thing is this trace.xml we need to convert into the mobility.tcl file. So for that we have a file called as trace exporter. Sumo has a trace exporter.py file. So this has to be processed. This file has to be processed. So how do we do it? Here is a command. So actually it is there in the folder called as sumo tools. You can see that we have in the folder called as sumo tools. We have something like trace exporter.py. So to run this file we need to have a command python space trace exporter.py, then -i. The input file is trace.xml. Trace.xml is in the next folder. So we have to use 2019 20, then trace.xml file, then ns2 hyphen mobility, I think something output will be there, ns2 hyphen mobility output. So hyphen mobility output equal to mobility.tcl. So I'm just storing the mobility.tcl in the tools folder. So here itself this file will be stored. And if you want to store the next folder, you have to store it. Give the location of the folder. So let me store it in the home folder, because I want to use this for my vehicular ad hoc network simulation. Okay. So once I do that, so there is some error, ns2 mobility, no gap I suppose. Yes, correct. So no gap. So this is the command. So this command I'm just using it. So I'll just give this command. So actually this work is a project. So if you want to do it as a project, it's you can convert this work into a paper, journal paper, and then you can publish it. So it's a kind of a work. So almost I am doing it for 2 hours. I am just running this entire project. Okay, so you can check the home folder, ls. You can see the mobility.tcl was generated. So I will open this mobility file. So in the mobility file you can check it. So this is the TCL file that generates node number 0, 1. The moment you go to the end of this file, at the end of this file we have to know the number of nodes in this file. So what we do is we'll go to the end and then just bring down somewhere. You can see the node creation. If you go too fast, you may miss the last node what was created. Just note down the points also. Yes, the node number is 32. So totally 32 nodes are created. Okay, so just make a note of it. And the timing, last timing what we have got is 249. So 249 and 32 seconds. So 32 nodes. So what I can do is from the mobility.tcl file, there are 32 nodes, or we call it as vehicles, and 249 seconds. So this is the simulation time. So this information is very mandatory for us because we will be seeing how to use this information into our network. Okay, right. So now what we do is, now it's our challenging task now comes up. Now we have ns3 part. Step number 2. So what we do is this ns3 part. So copy the file vanet-routing-compare.cc file to the scratch folder. So I refer part number 1 video for the location of this file. I will just do the copying here. cp ns all in one 3.27 /ns 3.27 src wave. Inside this examples vanet. This file has to be copied to ns 3.27 /ns scratch. So in this folder I am just copying it. The simple command I just do from the home folder. In case if you need, I will just give you. So please see that my home is /home/pradeepkumar. Your home will be different. So accordingly you can do that. Okay. So once it is done, now I will just go inside 3.27 ns 3.27 and this thing. Okay. So here I have in the scratch folder. I'll see the scratch. You can see the vanet-routing-compare is there. So just open this file, vanet-routing-compare. So I got this file. So here we have 2 scenarios. Scenario 1 is for running for 40 nodes and total simulation time is 10 seconds. And scenario 2, it is already reading from a trace file, this file. So maybe the line number 2392. In this what I do is I will just change this file to my own file. So here realistic vehicular traffic in this kilometer suburban Zurich like that is telling. So what I did, traffic trace in I will use my area, Selayu, Tambaram, my area where I live. So total number of vehicles is 32. Okay, so what I do is I will make 32 vehicles, but don't increase the number, because if you increase the number you will get some errors, some warnings or something, because you are addressing the cars which are not available, but you are addressing the simulation, so there will be an error. And total simulation time is 300. So if you need 300, you need more power for 300 seconds. Maybe I'll just show you for, let's say 30 seconds, 1/10 of it I will show you. Let's say how long it takes. And node speed, it is 0, it is given. So if you case node speed are 20 meters per second, and this thing. So for renaming, this is the trace file. What trace file I am going to use? mobility.tcl. So it is in the home folder, home pradeepkumar /mobility.tcl file. This is the folder that I am just storing. Okay. And I want to create a log file. So I'll give the name as mob.tsp.log. So mob Pradeep, I will put mobility pradeep.log file. I just create. Similarly, this also I create mob pradeep.csv. I just create. I don't know why there are two file names given here. So both I will give this mob pradeep. Any one file will be created. Okay. So this is how the way I am going to modify this work. So I am going, this protocol is going to read mobility.tcl, but for that the scenario 2 has to be used. Okay, so refer the part 1 video because you may not understand. I have explained the complete source code of this particular output. Okay, so now what I do is I will be running this code from ns3.27. so what I do is do the modifications in line number 2392 as indicated in the video. Okay, so my simulation will be running for various protocols like OLSR, ODV and DSDV. I am going to use 3 protocols and scenario 2 will be used. 2 is used for Selur, Tambram, Chennai, India. This is my location. Okay, so this I will be using, and total simulation time is 30 seconds. Vehicle movement is 20 meters per second. Vehicle movement is 20 meters per second. So this is what I am going to use in my. So first I will get these files. So what I do is wap _run within double quotes scratch vanet-routing-compare, no extensions, and the name of the protocol. If protocol 1 equal to OLSR, 2 means ODV, 3 means DSDV, and 4 means DSR. 1 for OLSR. We have to write like this. This command is like this. What the command is? wap _run / vanet-routing-compare space _protocol equal to 1. This is for OLSR. 1 for OLSR, 2 for ODV, 3 for DSDV, and 4 for DSR. This is what we will be using. And scenario will be scenario equal to 2. So sorry, double hyphen scenario. So double hyphen scenario. This command will be running. So then scenario equal to 2. So within double quotes you close this. Now I will be getting the file what I generated. So earlier I tried with the mob TSP, now I use mob Pradeep. Okay, you can see totally 30 seconds I have given. Now the protocol number 1 is OLSR. Okay. So the OLSR protocol values will be printed here. Okay, so now you can see we got various files like this. So mob pradeep.csv. So cat mob pradeep2.csv. So we got these many files for up to 30 seconds. So we'll see what are the how to plot. We will see these values how we will be plotting it. Then cat mob pradeep.log. So this is the movement file. So the mobility log file, you can see this is a log file we got generated for this 30 seconds of duration. How vehicles move, where it moves. Apart from that, we have something like vanet-routing-compare, vanet-routing output 2. This also got generated by cat vanet-routing.output2.csv. So this is a file that we got the basic safety messages. So BSM means basic safety messages. Again refer to the part number 1. So this is the packet delivery ratio for each and every factor. Please understand these are all the things for OLSR protocol. Okay. So now what I do is I will just convert this into OLSR. So all these things are OLSR protocol. So what I will be doing is I will just copy this data, Control C. I will create a new file, Control V. So this is for OLSR. Okay. So this BSM PDR up to packet delivery ratio up to 10, and the average PDR we got it here. Average routing goodput kbps is this much, and we got this 10, and the last thing is mac 5. Okay, 10.5437 is the average goodput, and this is the last one. Mac 5 overhead is this value. Okay, we got this value, and we will just save it now. Compare, I will put the file name as compare, store it in the. Now I will run the same thing. Similarly, mob pradeep to csv, this file also will change it to mob pradeep2.csv to olsr.csv. I will convert this to olsr. Okay, now I will be running the same simulation for protocol number 2. Protocol number 2 is AODV. So now you can see this, when the simulation was running, it was telling OLSR. Okay, so now you can see the simulation what currently running is AODV. Okay, this is for 30 seconds. So you cannot expect the same speed your machine may get. Your machine might be slow, because I have used I am using SSD device. If you use a hard disk, the simulation might be slow. Okay, and now this is what AODV is completed. Now again I will go here. Now this Pradeep mob this thing. Okay, I will just go with cat vanet output 2.csv. Now this is the value that I got it for AODV. So in this line I will print, then in the compare value I will just save it here. Okay, now you can see some packet delivery is 1 here. So first thing is for OLSR, for AODV. And again my command is move this file to AODV.csv. Okay, done. So AODV.csv. Now the thing is again enter in the simulation for protocol number 3, that is for DSDV. So DSDV now it is running. So DVC is still more faster. So let's see which protocol outperforms other protocol. Let's see. Okay, now again I'll go with this value. Now this is the value for DSDV. Control V. Okay, and this is the DSDV protocol. Then again move this to DVC. Either you can change the source code inside, or you can directly move it to the corresponding file. So that you will get all the files like this: AODV.csv, DSDV.csv, OLSR, and one more is pending in protocol number 4. Now this is the DSR protocol. So you can see that in the first level itself you can see which protocol is running. There is DSR, so you can understand whether which protocol is running. Now after we get this, we have to plot the characteristics. Okay, so cat vanet dot output. So this is for a DSR. So DSR, you can see there are overhead is PDR is completely 0. The basic safety messages have never been handled, so it is completely 0. And we have the goodput and the max physical layer overhead. So that is that. And again move and dsr.csv. Okay, so we have done all this for files. Now we will be doing the plotting. So first this thing is BSM. So BSM we have this, and if we run for 300 second simulation, I'll just check with it. In protocol number 1 for OLSR, I'll run it for 300 seconds. Let's say for 300 seconds, or let's say 100 seconds. You get the packet delivery ratio. You can have considerable varying in packet delivery. So what I do is I'll just read the file scratch vanet. So in this what I do is 30.01. Yeah, here what I do is I'll just use it for 100 seconds. 100 seconds I use it. Then I run it for protocol number 1. 1 is for OLSR. Now you can check it here. What is the basic safety message packet delivery ratio? You can check it here. Now it is compiling. Now this we have to wait for 100 seconds. 100 seconds, since it is 32 vehicles only, 100 seconds is fine. But in case if you want to go with more than 50, 100 vehicles, your complexity of the project will increases. In that case, you need to have 16 GB RAM machine or 32 GB RAM machine. So such kind of machines you need to have. So anyway, run it for 100 seconds. Let's see what is the packet delivery ratio happens here. So you can compare your results according to the protocol, according to the various nodes, according to the various mobility patterns, according to various data rates. So there are so many things that you can able to try out. So as per my suggestion here is, in using this experimentation, you can plot as many as 300 characteristics. 300. It's not a simple number, it's a very big number. So you can have multiple research works you can able to do with this particular one example. So I just given a sample of it, so you can try out with the various example. So FlowMonitor is very important tool that is available for handling packet losses, packet bit rates and other stuff. So I'll give a separate video for FlowMonitors. So how to use FlowMonitor in our applications. So that alone will take 30-35 minutes. Okay, now I can just show you that the simulation over. Now see the packet delivery ratio. So it has considerable varying difference here, and you can see cat mob pradeep 1.csv 2.csv. So you can see that. So up to 100 seconds how things are changing. So it shows you the receive rate and other stuff for up to 100 seconds. Okay, so now what I do is I'll just go and process the data what we already got it. Okay, so in the compare we have got it this many results. So first line for OLSR, second line for IODV, third line for DSDV and fourth line for DSR. Okay, so now we have to plot using GNU plot, or if you want to plot using let's say for example my Excel sheet, you can try out easily. So what I do is I'll just delete the last two things only I want: Mac physical layer overhead, and I need this goodput. Yeah, these are the two things we want. So you can see the number. Okay, I'll just save this as save as CSV file, and I'll just save as .csv compare.csv. So one method I'll just tell you how to do that, but this is not the method I will be following. I will be following other method. I'll just show you that how that can be done. So just open it. So it will open in an Excel sheet. Click OK. Then you can see these are the two values you got. So first line for OLS and other stuff. So what I can do is I use one more line here. Insert OLSR, AODB, DSDV and DSR. Or also you can directly use chart, insert chart. You can use histogram. So whichever way you want, you can use that. Okay, so you can use histogram here. So very good. So you have tried the histogram. Since we do not know what is x, y and z axis, so that's why we do not have any x, y, z axis, x axis. So that's why we have we can use this. So this column number L, and you can check it here. Format, insert data labels, and insert titles. So you can use the title of the graph. What is x axis? X axis is protocol. So you can use the protocol here, and y axis is there is what goodput and Mac PHY overhead. Okay, so you got it in there, and the title of the graph you can use it. So this way you can able to plot the characteristics. Now we can see that as per the goodput, which protocol outperforms other. Number 1 for WLSR, 2 for AODV, 3 for DSDV and 4 for DSR. So DSR protocol outperforms the other, whereas AODV protocol is next. Third thing is OLSR, and finally we have DSDV. So that is the goodput. Whereas the Mac physical layer overhead, Mac PHU overhead, as per the values you can see, the overhead is very less in DSR. So because we don't have considerable PDRs here, so that's why this value might be less. But other three things we have a good PDR, but you can see that here the best thing is DSDV. So we have overhead of just very 0.42%, but others have 58. A would have 58% and this have 50%. So this way you can claim some results. Okay, this is on one aspect. We'll go to the other file. Other file is OLSR, this aodv.csv, dsdv, dsr and OLSR. Open all the 4 files. Now we got open all the 4 files. Okay, so now I am going to plot in one waveform. I will be plotting the receive rate, packet received, transmission power, waves packet sends, wave packet received, wave packets PPR, expected wave packet received. So there are so many parameters we got it here, and the time also. So 1 2 3 up to 30 seconds we have up to 30 seconds. How was the physical layer overhead happens. Okay, this also we can plot. Okay, now what I do is column number 2, column number 3. So this column number 2 receive rate, column number 3 is packet received, and finally MAC physical layer overhead. In which column here? 1. So this we have to count. 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21 22. So 22nd column. So 22nd column, second and the third column. X-axis will be simulation second. Okay, this for 4 graphs. You can see DSDV also, DSR also, and YNR also. Now I'm going to write a code. Set terminal PDF. Set output. File name is receive rate.pdf. Then set title receive rate. Set X label simulation time in seconds. Okay, so then set Y label is the receive rate. Then plot aodv.csv using 1:2 means first column and the second column. Second column will be in the y-axis, first column will be x-axis. Okay, with lines points. With the lines points, title aodv, comma. Again we have okay, first thing is aodv, next thing is OLSR.csv using 1:2 with lines points, title OLSR, then comma dsdv.csv using 1:2, because everything first column and second column. See, what I am doing is one graph I am going to plot using 4 different files. 1:2 with lines points, title dsdv, then comma dsr.csv with using 1:2 with lines points space title dsr. A file, simple file, GNU code. I just name the file as GNU code.plt. Save it in ns3.27 because the location of all CSV file in the same folder I will be. So now what I do is GNU plot space GNU code.plt. There is some error. Line number 6, X range is invalid. Okay, I understand the reason. What is the reason is comma won't be processed using GNU plot. So we have to remove the comma. What we do is Control H, comma, find comma, replace with a space bar. You can see all things are replaced. Again you go to DSDV, replace all. Control S, then again go to DSR, replace all. Control S, then OLSR. Control S. So we have done it. Now see, no errors. Now I'll go and check the file. ns3.27. We have rr.ca. Yeah. We can see this is a graph that I got it for aodb OLSR. So you can see the receive rate, the value is 0 to 18, there is a receive rate. So what happens here? So these two, this orange and this violet color, so they perform well. So AODV and DSR perform well in receive rate. So other two, there are so many of variation. So when compared to these two, so this one graph. So what I do is, again I'll come back here. I'll just close it here. Now GNE code, just Control A, Control C, again Control V, again Control V. So now here is packet received. I name the file as pr.pdf. Packets received. This is the third column. Packets received. Packets. So 1:3. Instead of 2, we'll have 1:3 with the same file again. So we will not have any much difference. So this way you can create multiple files in one single file. So this package with PR. Now here this thing is Mac PHY. So it's the overhead. The title is Mac PHY overhead. So here the time is simulation seconds, right? This overhead. This column number 22. The 22nd column we have seen it already. In case if at all any errors is there, it will let you know what kind of error you got. Okay, so now we'll run it again. Yes, no errors. Now we go to the folder. Now we can see RR we already seen. Now we use PR. PR also same like RR because packet received, but the value here is 35. So almost double the size of what we got in RR. So RR have only up to 18, but PR is this thing. Now Mac PHP overhead is this one Mac PHP overhead. So this is the overhead it happens. Now you can see that the overhead I already discussed that DSR, the overhead is keep on decreasing right from here to here. When the number of time is increasing, it decreases. Similarly, AODV protocol also is increased up to a particular level, but the value maintains at 0.6 or something. But here this green color OLSR, the overhead is increasing. As time increases, the overhead is increasing. Overhead is increasing. And blue color overhead is increasing, again increases and again decreases. So this way you can able to plot the characteristics of all the 4 protocols. Now what we have compared is 32 nodes we have compared. So this way we can compare so many results in this vehicular networks. So GNE plot. So in this case, this is what the code we have done it. I'll just give the code also in GNE plot how to process the result. To process the result, we used GNE plot and spreadsheet called as LibreOffice spreadsheet. So here is the GNE plot code. GNE plot code. For this code to run, so you need to have all the CSV files available in the folder. As per the command, as per the video, you can refer for this video. So now we have done the basic simulations and plotting of characteristics. Similar way we can do it for other results also. In the next video I will be showcasing how to use FlowMonitor for plotting the various losses, bit rates in the system or in the network. So this we will be seeing it. So we will be using Python script to read it. Python scripts to read the simulations. Sorry, to read the FlowMonitor. FlowMonitors. So FlowMonitors are very powerful. So thanks for watching part 2 video. Thanks for watching. Please share the videos to your friends and ask them to subscribe.